Okay, this is Unit Test 1, Video Solutions, questions 9 and 10. And, question number 9 here is very calculus-like. It's the kind of thing you could see in certainly in Calc 1. We're looking at 3 times the quantity 2x minus 1 squared times a 2 um, to the x plus 3 to the 1 half, then a plus sign, and again a quantity 2x minus 1, but this time to the third power times an x plus 3 to the minus 1 half power. So as we've mentioned before, you need to see the structure, and basically we have 3, say, a squared, and then down here you have that same a cubed. So you have that common element right there. Likewise with the x plus 3, you see an x plus 3 right here, and you see an x plus 3 right here on different sides of that addition sign. So you have a common element there. The trick is to factor out the common elements. The lowest power term is what you want to factor out. So 2x minus 1 squared, 2x minus 1 cubed, we're going to factor out 2x minus 1 squared. Likewise, we have x plus 3 to the 1 half. We have x plus 3 to the minus 1 half. So we're going to factor out x plus 3 to the, you guessed it, minus 1 half. You factor out the lowest power you identify, and minus 1 half is lower, is less than 1 half. So you factor out the quantity to the smaller power. Now, when you do that, I'm going to leave a brace here. I'm going to leave a bracket and see if you can identify what remains when you divide these things out. Well, plainly, the 3 is going to be there, and the 2 is still going to be there. But that 2x minus 1 squared divided by 2x minus 1 squared, from this first part of this expression, the 2x minus 1 squared is going to disappear, so to speak. Actually, it turned into a factor of 1, right? Now, in terms of the x plus 3, and we've had a few questions about this, think about how this is going to work. You're dividing. You're dividing two expressions with the same base. So elementary algebra tells you that if you divide two numbers with the same base, you subtract the exponents. And 1 half minus 1 half, right? 1 half minus 1 half, you're actually going to add, and so that's going to be x plus 3 to the first power right there. Now, as you look at the second pairing here, the 2x minus 1 squared was factored out. You had 2x minus 1 cubed here, and so that's going to leave you with a 2x minus 1 to the first power. And of course, the x plus 3 to the minus 1 half, that was divided out, that was factored out, and so x plus 3 to the minus 1 half divided by x plus 3 to the minus 1 half gives you a factor of 1. Now, if we continue by doing a couple things here, 2x minus 1 squared, I'm going to leave it right where it is, but the x plus 3 to the minus 1 half, I'm going to move that multiplied term, again, it's multiplied, I'm going to move that term to the denominator. And it's now going to still be x plus 3. The base isn't going to change. But when you move a multiplied term from a numerator to a denominator, what happens to the sign of that exponent? Well, it turns into 1 half. And then if we do the algebra in the braces here, this is going to become 3 times 2 is 6 times the x plus 3 is going to be 6x plus 18. And then a 1 distributed through here, of course, gives us plus 2x minus 1. And a little more arithmetic to do in there. And we've got 2x minus 1 squared times 6x and 2x make 8x plus 17, and then a denominator of x plus 3 to the 1/2. Now, finally, the other thing we'd want to know, x cannot be negative 3. Negative 3 would be excluded from your domain because if x is minus 3 plus 3, that'll make a 0 in a denominator. That causes a division by 0, and so we want to identify that, very important in the calculus. This question number 10, we've got y to the 4th. Again, separation by a plus sign there, so we've got y to the 4th. And then y plus 2 to the 3rd. And then a plus, turn that into a plus sign. Y to the 5th times y plus 2 to the 4th. So hopefully you're seeing structure now. You're seeing the common elements, y to the 4th and y to the 5th. Factor out the lower power, so you're going to factor out y to the 4th. And you see a y plus 2 in both terms, separated by this plus sign. Factor out the lower power, so you factor out the y plus 2 to the 3rd power. And then you ask yourself, when you factor that out, you factor out those common elements from each term, what remains? Well, y to the 4th divided by y to the 4th, that's just going to give you a multiple of 1. And the y plus 2 to the 3rd divided by y plus 2 to the 3rd, that's also going to give you a multiple of 1. So there's a 1 that remains in that position, not a nothing. When you're factoring, you're dividing. So y to the 4th, the quantity y plus 2 to the 3rd divided by y to the 4th, y plus 2 to the 3rd, leaves you with a factor of 1 right there. And then the y to the 5th, divide out y to the 4th, that's going to leave you with just a y. And the y plus 2 to the 3rd being factored out of y plus 2 to the 4th, it's going to leave you with a factor of y plus 2. Now, we have factored it, but this term in here can have a little more algebra done to it. So I'm going to go up here and do that algebra. There's the y to the 4th. There's the y plus 2 to the 3rd. And then working within these parentheses, I hope you see we're going to have a y squared plus a 2y plus a 1. Doing distributive property here, and then rearranging to standard form in terms of exponents. And that would be great, except y squared plus 2y plus 1 is not algebraically prime. That can actually be factored. And it's sort of a special case. It's actually a square. So when you factor that piece, everybody should see it as a y and a y. Signs are telling us that both signs are positive. And to get a 1, it's going to be a 1 and a 1, which would be a legit answer. It should, and I think WebAssign would take this algebraic answer if you wrote it y plus 2 to the 3rd times y plus 1 squared. All right. So I believe either one of these WebAssign would have accepted. I'm not really certain, but I think they did. So that's questions 9 and 10 from unit test 1. And we hope you found them helpful. And if you have any questions, that you'll definitely get back to us. See you tomorrow with more about equations.